Okay. Y'all can hear me fine? You can see my screen? Yes. Something wrong with my speaker, but just quiet.
No, just quiet here. Just give me a second and we get back on my laptop.
All right.
Yes, sir. Hearing you.
All right, no problem. Okay. All right. Let's get started. So, the stuff that we'd have already covered so far. In the first part of the course, we did a bit of theory. We talked about APIs. We talked about the client-server relationship. We talked about JSON. We talked about REST APIs. It was REST APIs. Yeah, I think REST APIs is what we talked about. The different HTTP requests that we can make and how they are handled on the server to provide a response. And we also talked about how a client in a scenario like that doesn't only have to be the web browser. A client can be any entity that is making a request to our server or to our API. So what we're going to be moving into now, since we finished the full CRUD processing or process of an HTTP server using Fast API and MongoDB and Python, is we're going to be looking at how we can consume those APIs that we built out. So the code that we've been writing so far, we use that to provide the API. So now we need to write the code to consume the API. And that code will live on the client, whether it be the browser or the Mac controller that we're using or whatever other device or platform that you want to use to actually make requests to those APIs. So instead of using instead of using Postman to make our requests, we're actually going to be building out the clients that will be doing the same thing as what Postman is doing, so that we don't need Postman anymore. All good? We're clear? Any questions on that? If you don't want to unmute, you can also thumbs up in the chat.
No question as it, sir.
No questions. All right, cool. So if you can see my screen, you should see my VS Code. We're going to stay in VS Code for when we're writing our code here. We're going to be writing some Arduino code, but we're not going to be using the Arduino library or the Arduino IDE for a few reasons. One of the simple reasons is that we started off in VS Code, so we will continue in VS Code for simplicity. Also, we're going to be using a library, an extension in VS Code called PlatformIO, which allows us to build out our applications or build out our sketches, our Arduino sketches, in a way that's more project friendly. Originally, like for example, if you have your Arduino IDE, let me see, Arduino IDE, let me open mine. So I have my Arduino IDE open here. If it is a case where you're writing some code for your Arduino and you want to include some libraries, you can install a library into your Arduino sketch. Do that later. So you can always include some libraries. So like you could click on manage libraries and you're able to search for libraries here and you can add them to your Arduino project, right? But if you want to share that code, the .ino file, if I share that code with somebody else and they run it in their Arduino IDE, they won't be able to run it unless they already have those libraries installed. And the only way that they can know what libraries to install is if they look in the code and say, oh, this code include wire.h and it include Adafruit, blah, 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 right? So I got to go and see if I can find those myself. So similar to how we write our code in Python, in Fast API, and we remember to include the requirements.txt, that way the environment that you're working in can automatically run some command to set up the environment in a way that matches the way you built it. we can do the same thing in PlatformIO. As far as I know, I don't know if there's no way to do it, but as far as I know, there's no easy way for us to do that in Arduino. Yeah. So that's what we're going to be using, PlatformIO, and I'm going to be showing you how we can go through and do all those stuff in PlatformIO. So, assuming you guys saw my instruction in WhatsApp earlier, you'd have already gone and downloaded PlatformIO using the extensions. So you type platform, and it should take you to PlatformIO, and you install it. And once that finishes installing, the instruction I gave would have told you to go to the left hand side. You click on PlatformIO, you scroll down to miscellaneous, and you click on PlatformIO core CLI, and you run the command to install the Expressive ESP32 Arduino framework. And the reason for that is when we get to a certain point in creating a project for ESP32, when you click create project, it's going to go in the background and it's going to download some libraries and dependencies that are required for us to write code and upload to the Arduino. And because you don't have them by default, it's going to download them while the project is created. And it won't create the project until it finishes downloading that package. And in my experience, when we do that at school on Mona Connect, that usually takes forever or it doesn't work at all. So I'd have given you instruction to get that done before so that we don't have that problem during class time. All right. Okay, so at this point, let me ask the question. Do we have PlatformIO installed and up and running? Are we all looking at PlatformIO on our machines now?
Yes, sir.
All right. Teresa, oh, you raised your hand and, oh, okay, no problem. All right, cool. So what we're going to do, I'm going to click on here. I'm going to click on open in the PlatformIO extension. Okay. I'm pretty sure yours is going to look different from mine. I don't know what I did to make it look like this, but you can ignore it. I think you should have the alien face here instead of this blue PIO Arduino thing. Yeah, some time ago I was doing something and I installed something and it changed it. But I don't think that change matters all that much. All the UI and all the steps, they follow exactly the same. So what we're going to do is we're going to get accustomed to PlatformIO. So in addition to this image here looking different, you may also find that you don't have a list of projects below on your screen. But I've been using PlatformIO for a while, so I'm going to have a list of projects here. What we're going to do is we're going to start off by creating a new project. On the right hand side, we click new project. And it's going to give you a few options, a few things that we need to type in. Project name. Since this is new, we're going to just test out the ESP32. One way we can test it is by just making an LED blink. So we can say ESP32 blink test. I believe if you use spaces in the name of your project, it will fill it in with either dashes or hyphens. I don't remember exactly what. But yeah, I usually just don't include any spaces in my names. So you can do the same thing if you want, or if you want to put spaces, I think it will automatically fill in the hyphens for you. All right, so for board, given the boards that I have available, I usually tell people to look for dev module, the Expressive ESP32 dev module, but you choose whichever ESP that you have. The ones that I have available are the dev module. The ones that people have very often are the dev module. And so I'll just tell people to choose this one. So that's what I'm going to use. And the framework, we leave that on Arduino, not ESP-IDF. That's a whole different thing that we don't really want to get into. It's a whole lot more complicated than Arduino. All right. And then we let use default location stay. I think this is going to basically write the project to your documents folder, if I'm not mistaken. And then we should be able to click finish. And it's at this point that if you don't already have the stuff download, it's going to hang on the screen. The stuff being the stuff that I would told you to install before class time. So it would have hung on the screen and it would have taken a good while for it to actually finish. Now I'm concerned that mine isn't going to finish. I wonder why. Wonder why mine taking so long. Did I not download the stuff that I needed? Let's hope that that isn't the case. Let's hope that my computer is slow. All right. In the meantime, can we confirm that you guys are not having the same experience as me? Or you already?
Same loading.
Oh, it's same loading, really? All right. Well, we'll wait together.
Already.
Say again, yours is finished already?
Yes.
Okay, that's good. So yeah, I guess what we can do in the meantime, we can maybe get accustomed to using Wakwi, which is the simulating tool that I would have told you about, that we can use to simulate the workings of an ESP. I also found out about Tinkercad, which is what I think Yekini uses in his class. Wait, does that use ESP? No, I think that uses the Arduino Uno. So maybe we wouldn't be able to use that. But yeah, we can use Wakwi though. So I'm going to go to Wakwi. ESP32 simulator. So we'll go to Wakwi. This is what Wakwi will look like. Let me close this. We'll click on ESP32 and it gives us a bunch of different examples, that we can use that have already been built by other people. But the simplest one, I guess you could use, since, I guess depending on what it is you want to test, we can just choose this one. Looks like it has LEDs already on it. Let's see. So this one has two LEDs connected to pins 26 and 27. And it looks like what it does is it connects, it sets up a HTTP server. Interesting, but we will not be doing that. We're not setting up an HTTP server. We're going to be running our server on our machine, and we're going to be making requests to that server using the ESP. Now let me see. If I'm not mistaken, I don't think you'd actually be able to make requests to your server on your machine from Wakwi. You typically would have to make the request not to the server on your computer, but to the server on the internet. So you'd have to have your API application running on an internet-enabled server for you to be able to make requests to it from Wakwi. If you want to be able to make requests to it on your computer locally, I think you'd have to get the Wakwi extension in VS Code, which I think is something that we can do. But yeah, all right, looks like mine's finished. Everybody else is finished, or are we still waiting?
Still hard.
Still waiting. All right, no problem. All right, give me 1 sec.
Sorry for my lateness. So where do I again?
We're moving on to PlatformIO.
Yeah, but we're supposed to supposed to create a project.
Yeah, so I created a project for all of
All
All
right.
right, one moment. Oh wait, that's a minute long? Or did I? Okay. So if yours is already open, we're going to be focusing on a few things, but the first thing that should come up is the PlatformIO.ini. So the PlatformIO.ini file is going to be somewhat similar to your requirements.txt. It should store some default parameters that PlatformIO needs to know in order for it to interpret the code that you've written and also be able to upload to your microcontroller or your ESP. So,
Excuse me, sir.
Yeah, go ahead.
You're recording, sir?
Yeah, man. Should be.
All right.
Yeah. So yeah, some default settings that we need. I'll close this and zoom in. Some default settings that we would need to make it so that PlatformIO can interpret the code that we're writing and upload it to your microcontroller. And this is also where the library references are going to be stored, but we don't have to write in those libraries ourselves. We can use PlatformIO to import a library into our project, and then the reference to that library will be stored here in this file. I'll show you how to do that in just a second. But okay, let's see. First thing we're going to do, very simply, let me see if I can find my notes. We're going to be looking at how we can very simply make a GET request to some server. All right. So in order for us to do that, we're going to need to write our code in the source folder in the file called main.cpp. And it's going to come with some placeholding code that we're going to get rid of. We're still waiting on the code or on the project to create, or are we good?
Well, I'm still waiting. Going to the project wizard thing, sir.
Okay, all right, no problem. Okay, so I guess in the meantime, you can just go and pay attention and follow the recording later or something. But you should be able to write the code and then upload it to ESP after when the project is created. So like you can probably open like another VS Code somewhere else and write the code and follow along. All right, I'm going to get rid of this code. Everything except for the first include that I have at the top. So if this was the Arduino IDE, you would not require this line that says include arduino.h, because I'm pretty sure the arduino.h library is something that is included by default in the Arduino library. But because we're not working in the Arduino library, it's not explicitly imported. We're using PlatformIO, which is not only for Arduino. So we'll have to explicitly import the arduino.h library so that it knows the code that we're writing is Arduino code. All right. Two other important libraries that we need to install. Since we're using an ESP and the ESP needs to be connected to the Wi-Fi in order to make requests, we need to include Wi-Fi.h. I'll put it in angle brackets just the same. So including Wi-Fi.h, which should be built into Arduino, so we don't have to manually install it. And another one that we need to include is include HTTP client. HTTP client.h, which is also built in, so we don't need to install it manually. The HTTP, well, the Wi-Fi client obviously is the one that allows our Arduino to connect to the existing Wi-Fi that we have around us. And the HTTP client is the library that you use to make it so that it is able to send the requests that we have written code to provide by our API. So HTTP client has methods for get requests, post requests, put requests, and delete requests. I think it has patch. I'm not sure. I'll have to check and see if it has that. But yeah, we should at the very least be able to do a post, a put, and a get. All right. Okay. So cool. Let us next. All right. I guess what we can do. All right. Should we start with a Wi-Fi related test first? I guess just to make sure PlatformIO is even working. And maybe we should just start with a blink test. So let me get rid of these for now. We don't need them. I just can copy them out. Go ahead.
We don't create any virtual environment.
So virtual environments are specific to Python. We're not doing virtual environments here.
Okay.
Cool. Okay, yeah. I commented out these lines because we just want to actually make sure that PlatformIO is working and is able to actually upload to the ESP. So let's just do a simple test that makes the LED on the ESP blink. All right, so we're going to do the same normal set we normally do for Arduino. We'll have a void setup. Setup with a lowercase s, right? Setup. Yeah, and a void loop, right? Okay, why is this red on the line? Okay, never mind. Okay, so
Yes, sir.
question.
Think it finished already though after?
Oh, it finished. I went into the source folder and clicked on main.cpp and I cleared out the existing code.
Just stop and go back push by the alien.
I don't think you have to. I think it should see this on the left, right? These folders and files.
You
You not seeing that?
Open project example. You not even see project or just
Really?
open existing
All right.
project.
Maybe go back to home. So click on the alien face again and go to home and then click open. and see if you see any projects down here.
Uh, no.
No? Alright, maybe you need to create a project again. Try that. Just go through the process of creating any project again. And the board is dev module. ESP32 development module or something like that. Try that and hopefully it works. I don't think it's going to need to download the framework again. It should have already downloaded if I'm not mistaken. All right, but yeah, in the meantime, so I'm assuming that by this point, for where we are right now, I don't think I'm going to need to explain the code I'm writing, right? Because we are familiar enough with Arduino that I don't need to explain that we need a setup and a loop. If I do need to explain, let me know and I'll explain it, but just let me just a confirmation. I don't want to leave anybody behind. Don't want to assume that we don't know this stuff. Okay, so silence means we're good. Okay, so, all right, so setup. In the setup, we're going to let Arduino know or let PlatformIO know that we want to set up a particular pin as output. But what pin are we going to use? What's the LED, built-in LED pin? Built-in LED ESP32. Someone else has joined the call. Rainer again. Okay, so let me see. Built-in. Oh, it looks like we don't actually need that particular pin. It seems to be pin 2. But what we can do, instead of using pin 2 explicitly, we can just go like this. Pin mode. And we can say LED underscore built in. Built in. Does that not work? Did I spell built in wrong? Okay, so this. Or do I need output?
Sir, mine say undefined.
Really? That's crazy. This should work. Oh, all right. Maybe it's a Arduino thing and not a PlatformIO thing. All right, never mind. I think it's supposed to be pin 2 in any case.
Yeah, question. You have to create the main.cpp.
It's already there. It's
Uh,
located inside the source folder.
SRC.
You see it?
Yeah.
Okay. All right, yeah, I thought LED built-in would have worked, but oh well. So we set it to output, and I feel like that's all we need to do for the setup, right? All we need to do now is just make it blink by using our pin mode. LED, oops, pin 2, high.
I think a digital right for
Yo, so
Arduino.
you're right.
You're right.
My mistake is a good thing you catch it. Obviously, I was just testing you. Digital right. We'll do it for 1,000. And then we do this again. Put this to low. And delay for 1,000. Okay, where's my ESP? One sec. Okay, gonna confirm that pin 2 actually does work on my ESP. Okay, and for us to build this now, we save our code as usual. And here down at the bottom of the screen, you'll see a few buttons. The build button is what you use if you just want to make sure that your code compiles. So you can click on that just to make sure it compiles. And if you want to, wait, what? Oh, okay, ignore that. If you want to make sure it compiles and uploads, then you click on the upload button. So clicking on upload will both build and upload. So if you don't want to wait on the build to happen by itself alone, you can click on upload and it will do both. I'm going to build just to make sure that my code compiles. And it is building, it's compiling. Why is it initializing Flutter? It's weird. I believe that because this is the first time we're doing this in this project, it's going to take a while. And I think subsequent builds should go faster, hopefully. Okay, so it's built successfully. Now I will upload. And if I'm not mistaken, there is something going on behind the scenes to make it so that it automatically detects what COM port your Arduino is plugged into. And I can show you where PlatformIO lists your connected devices in the event that it doesn't detect that it's connected. So mine says COM port 12, auto detected to COM port 12. And it's uploading now. And I'm looking at my Arduino, my ESP I mean, and it's blinking. So there's a blue light on mine that blinks for 1 second. Yeah, so in PlatformIO, you can go to PlatformIO and you can go to devices. You click on devices and it should show you a list of the connected devices with all the COM ports.
So hold on, you click on the platform, you click on the platform IO icon, forget that something.
Yeah. You can either do that or you can go to home. So you click on the face and go to home or open. You can scroll down to devices. And it will show you a list of connected COM ports. These two here are my Bluetooth. And then this one is my what's it called? Oh, you know what you need to? Assuming that you've never done this before, you're also going to need to install the ESP32 drivers. Is there anybody here that has not connected an ESP to their machine before? Do we need to go through installing the drivers?
Yes, sir.
Okay, no problem. Okay, let me just copy this. CP.
Yeah.
Yeah.
Even if a normal Arduino purposes.
If it's just a normal Arduino, I don't think you need drivers. But if it's an ESP32 specifically, you're going to need to go through this.
Yeah, but if we've been programming ESP on the Arduino IDE, we would have the drivers.
I believe so. I
It's
want to say yes. As long as you're able to build and compile, no, not even build. As long as you're able to upload to the ESP from PlatformIO, then you should be good. Otherwise, you're going to need this. I'll post a link in the WhatsApp. Click on downloads, and it is the universal driver that we need.
So you have a next one too.
Copy link address. So I'll post this in the group. ESP32 Windows. I think this works by itself on Mac. Windows drivers. Alright, so I posted the drivers. You just unzip that and install it like normal. And it should detect your ESP afterwards. So were we able to get our code uploaded to the ESP? Yes.
Repeat what you said, sir.
I was just asking if you're able to run it and get it installed. Like, what I mean is, write this code and upload it to the ESP. Or do you need to install the drivers?
Give me a second, that's what I'll tell you.
Okay, well, if that worked, the other thing that we need to make sure is also working is serial. So we're going to do some serial communication as well. In the event that we need to write some code that prints something to the screen or print something to the serial monitor rather, we can do that as well in the same way that we always do it in Arduino. So it's a serial dot begin. I will specify the baud rate. Children use 9600, big people use 115200. Don't ask me why. 115200. Yeah, and then we can say, I can get rid of this. I can get rid of this. Serial dot, where I got print line. Okay, just for 2 seconds. So I'm going to write this to my Arduino now. I save this and upload. Not my Arduino, my ESP. And then if you want to see it works, after it writes to the ESP, there are times when it will automatically open the serial monitor for you, but if it doesn't, we click on this plug icon that says PlatformIO serial monitor. So we'll wait for it to compile. It's uploading, it's connecting, and it's flashing.
Yeah, we're using the physical ESP.
I'm using a physical ESP now, but if you want me to show you the simulated, I can show you in a second. Okay, so it didn't automatically open the serial monitor, so I'll just click on this. And it should start printing. Hello, oh wait. Oh, okay, so I know why this is happening. It's because of the baud rate thing. By default, PlatformIO is 9600. So I need to tell it to use 115200 instead. And to do that, we go into the workspace, click on platformio.ini, and we will write a rule that says monitor speed is equal to 115200. Obviously, you don't have to do this if you want to stick to using 9600, which is fine. But I think I would need to close my terminal, reopen it. Wait. Oh, I think it seems to be reconfiguring PlatformIO. Now I can click on the plug, and it should open in 115200, and there's the word hello every 2 seconds. Yes. This good?
Yeah, then jump back to the code.
Back to the code.
So I'm still get garbage.
Really?
Really?
You use serial that begin 115200,
Yeah.
and you set your monitor
So
speed
your
to
monitor
something.
speed is
Make sure it's the same number.
same number.
11,200.
Mm-hmm.
Yeah, I'm gonna do that.
And then you close your terminal and
You
reopen
close your
it.
terminal and reopen it.
If I kill the entire terminal,
Well, you don't have to kill it. You can just
You don't have to
click
kill
the
it. You can
X,
just
or just kill the one that's running the serial
look
monitor
for
thing.
the serial monitor.
I guess just to be safe, you can kill the
Actually,
whole thing.
see, you can kill it.
I know that.
Wait, alright, now, okay, cool, good.
So,
All right. So with that, we can confirm 2 things. One, we can write to the ESP, and also we can read from the ESP. So we're able to write our code to it, and it will take our instruction, and then also read what the ESP spits out after it does some processing, right? Because we see the word hello come up, right? Okay. Next thing we need to do is we're going to look at how we can make a request to the ESP. All right. By the way, at this point, since Tyrese asked a while ago if I was using a physical ESP or if I was simulating, do you want me to show you how to set up the simulation?
I did. Yeah, I think I got
Wait, no, sorry. I didn't hear what you said. You want me to set up the simulation?
yeah, I can do that.
Okay, all right, we can do that. Let me see if I can remember how to do this because I don't remember. I go into extension and I type walk. Oh, did I click the wrong thing? Extensions. Walk. Walk with simulator. I already have it installed. Interesting. New version of what? Okay, not this. So go to the extensions and install Walkway. And then, yeah, explain remember how to do this. I Google this again. Walkway VS Code. Getting started. So, oh, start simulator. Interesting. Let's try that. I'm gonna go back to this. I'm going to press Control Shift P in VS Code. I'm going to type Walkway. Let's start simulator. My license expired. Wait, I'm not using the paid one. Am I? I don't think so. Okay, license. Click the button to generate a personal 30-day license. Interesting. After clicking on that, okay, so let's get a 30-day license. Open. Okay, I got a license. I don't know if you guys are going to need to do that. Maybe it's because I use a 30-day license and then it expired. So I need to get a new one. So let's try it again. Control Shift P and type Wakwi and then click Start Simulator. What? Oh, it needs a TOML file. All right, hold on. Let me actually read this and see what it says. So installation, you do that. Then your example project. So to configure Wakwi in your own project, oh, you need the project configuration. If you want to get started quickly and play around with that, here are some examples of pre-configured diagram on Wakwi. Okay, so I should be able to just download this file structure. So this is the diagram.json. Can I just copy this? Each simulation project contains a diagram.json file. And then this one is a TOML. Where's the TOML? All right, let's copy this.
We need the Walker simulator in VS Code, right?
Yeah.
Oh.
So I'm going to go diagram.json. Paste it. Oh, whoops. To paste it, I'm going to have to right click it. Because by default, when you click on it, it's going to open using the Walkway simulator. So if you want to actually type stuff in it, you right click and you click open with, and you go to text editor. And you should be able to type text in it. No. Wait, do I need to do that? Because if I could just... Okay, I guess not. I don't know. Anyway, save that. That didn't do anything. Anyway, let's go to the TOML now, the work with TOML. A basic TOML looks like this. Oh, we're gonna have to specify where the hex file is. Firmware. Copy this and create a walkway.toml. TOML. And paste this. I'm going to have to specify where these files are, and I don't remember where they are. I think they are going to be in PIO. It's been a while since I've done this, but give me a minute. Let me see where this says to do it.
When the free license expires, can I get the next one?
Yeah, I think so, because I don't think I've overpaid for it. Let me look up the... Okay, maybe we can just use this. Oh, this is ESP32. Is what we're supposed to do? Let me confirm. Walkway.toml PlatformIO. Yeah, but I don't know this. Oh. Build. So there's a build file here. ESP32. Okay, maybe we can use this. Walkway.toml. And we change this to ESP32 dev. ESP32 dev. Copy this, put that there, save it. Let's see if this works. Okay, now what? I need an ESP. Hold on. I think we need to get the ESP from Wakwi itself, you know. Let me go on Wakwi's site and then copy their diagram. Yeah, just copy this and then edit this. Put everything in there. So save it, and now I have an ESP. Okay. So now how do you write this to walkway? Like this. Firmware. Do I need to build? Where does the bin file get stored? Oh. Bin file. Oh, so there's the bin. So it should be where I said it was. Build ESP32 firmware.bin, which is here. Yeah. And then the wait, is the ELF file. Didn't I need a hex file? Oh, it is an ELF file. Okay, so both of them are there for me now. So I should be able to go like this. What? Did it not work? Did I spell something wrong? ESP32 dev firmware.bin. Unless I don't need this. The dot slash. Don't need this slash. Let's see. Okay. Progress. Okay. It works. So this is my simulation running now. This serial monitor we're seeing is a simulation. Let's go through that formally now. Let me stop this. I'm going to copy and paste this in a code share for y'all. And this file is what you'll use as your walkway.toml. Walkway.toml. So we'll use that for the walkway.toml. And then we can use this for the diagram. Let me copy this. Open with text editor. Copy this. I'll use this for a diagram.json. Oh wait, I need to add this first.
Anyway, diagram.json.
Come again?
What does the diagram.json do?
What that does is it allows you, it basically draws the circuit for you. So it's a JSON that specifies the configuration of the circuit.
Draw the ESP and everything.
Right, yeah. So what I did to get mine is I went on Walkway's website and I opened up one of the existing projects. Where is Walkway? Hold on. Yeah, so I just opened up one of the existing projects and clicked on the diagram.json and just copied this. So because I copied this exactly, it came with the LEDs and the resistors and everything. So I'll just share that in another code share.
So the first code share goes where now?
The first, you just create two files in the root of your project. So right next to everything, right where the PlatformIO.ini is, you put a walkway.toml and a diagram.json.
Walkway.toml. And in the walkway.toml.
Yeah, inside it you paste this. So I put this in the first code share.
And then I'm I put the JSON for draw out the circuit.
The diagram.json, right? And in order to edit that, if you have the walkway extension, if you just click it normally, it's going to open up the diagram. So you'll have to right click it and then go to open with and then click text editor. And then that will allow you to edit it.
Alright, click open with text editor.
If I'm not mistaken. Yeah, I don't think you'll be able to actually make changes to the circuit here in VS Code. So you'll have to go on the website, the Walkway site, make changes to it there, add your different
Then
components, and then copy out the diagram. That is my understanding of it. But yes.
Yeah, but having the simulator extension shouldn't we be able to?
I think it asks you to pay for it. I think that's why. Yeah, so when I click edit, just upgrade. Yeah. But you can edit it on the website and then copy out the diagram, which is also an option. Let me do the LED one.
Yeah, just run down it and it's supposed to run now.
Yeah, you can just go into the diagram and click on the play button. And it should just, as long as you build first, so that it creates the elf and the bin.
It's failing.
Align.
Please specify upload port for environment.
What? You shouldn't need to do that. This is. Wait, which one you click? You click build or upload? Click build. This is the
Build.
check.
Build successfully. But when I get the hello, oh wait, I have to do the plug.
I don't think so. I think you have to just click the play button.
Enter port index or full name. Huh? Same code.
I will write blink to man and see if it blinks in the simulator.
Is the serial monitor supposed to say hello?
I think it's supposed to just be in Walkway's terminal. So Walkway have a terminal by itself that it just writes to.
Yeah, it's away for that terminal.
I think it should open when you just click the play button in the diagram. So I should be able to go like this now. And it should blink. It did not blink. Did I do this wrong? Pin too high, pin too low. Unless this thing now have a LED on it. Well, this is the power LED, but I don't know if it have a pin 2 LED. Okay, maybe this ESP don't have it. Which ESP is this? Oh, this ESP is slightly different from the one I have. This one has a ground pin at the end, but mine doesn't have that. Okay, maybe this one just doesn't have the built-in LED. I don't know. Oh, can use pin 26. Use pin 26 instead.
Because they work with firmware, binary, something.
What about it?
Not found in workspace.
Not found. Alright, share your screen.
Sure, sweet. Show screen, I turn on the camera.
Oh, I didn't do this.
Bro, I'm gonna take out the background.
You have to turn on your camera. You don't have to turn on your camera to share screen.
Oh, no, it's a different device.
Oh, okay. How about everybody else? Everybody else good? Just checking.
Using my ESP.
Using the
Real.
physical ESP. And it works on the physical ESP?
Yes.
Okay, good. I think Matty should be good. Rain, how about you? Think good? Hey, LED works.
Error. Me and for night.
What's that?
Talk out my ESP already. Hopefully the code. I have the code. This is supposed to automatically phone the ports.
Yeah, it should if it's a physical ESP, yeah. Assuming the drivers are installed.
Then no. Clear off that and just run the code.
You can test out and let me know if it works. In the meantime, we can go on to doing an example that involves making a request.
Serial alert and serial alert.
Okay.
Yeah.
Work now?
Yeah, come.
Sorry?
Yeah, come.
Okay, cool.
Isn't something like this you gotta do for the project?
Yes, but a little bit more complex. But yeah.
So now they're able to use the online ESP.
You can use either one.
True, this never did that.
Don't have what?
I said, true, it never did that work.
Oh, well, yeah, whichever one works, you can use it.
Ah.
Yeah. All right. So we're going to go back to the example that we were started writing that makes a request to some server. So I'm going to uncomment these two lines because we need to be able to connect to Wi-Fi and create an HTTP request. Okay, so first thing we're going to need to do is actually connect to Wi-Fi. Where is... Okay, so connect to Wi-Fi by setting up our SSID and our password in our code. But similar to how I would have told you not to put your database connect string in your code, you're also going to want to treat your SSID and your password for your router or your Wi-Fi as sensitive. We're not going to be using a .env file. We're going to be using a .h file, or what was it? I guess we can call it anything.h or config.h. Actually, no, we should formalize what we call it, because whatever we call it, I'm going to have to provide my own. And if you call it something else different from me, mine not gonna work. So what I'll do, we'll go into the include folder and we will create a new file and call it config.h. Then we will create two variables. One variable is the SSID and the other variable is the password. So you'll replace your SSID or the placeholder values here with your actual SSID and your actual password for your Wi-Fi. And then you will add this config.h to your git ignore so that it does not get posted to GitHub. Config.h. Okay, cool. I think Wakwi also allows you. Wait. How you connect to Wi-Fi in Wakwi? There's definitely a way to connect to Wi-Fi in Wakwi. VS Code Wakwi Wi-Fi. Do I connect to my actual Wi-Fi? Or do I use this? Let's see, I can use this, and then there's no password. Do I have to specify the channel? I don't remember. All right, for now, let me just use this and see if it works in Wakwi. Okay, so going back to the HTTP setup. We need to specify another thing. We need to specify which server we're making the request to. So I'm going to create another variable here, and I'll say string server name and set that equal to, actually we need to specify which server we're going to make a request to. So let me pull up a placeholding server. I think I can use a Star Wars API. Star Wars API. So yeah, there's API that you can make a test request to. Are there two of them? Swappy Dev and Swappy API. Oh yeah. Are there two of them? Okay, let's make a request and just test out getting back on something there. A response. All right, this one look complicated. This one's simpler. Okay, if I make a request to swappy.dev/API people/1, I get back this response. Okay, let's test it out in Postman and see what happens. So we're going to test out in Postman first, and then we're going to write the code to make that same request to what's it called? Make that same request in our Arduino, in our ESP. One moment, I'm setting up. What is this? Why Postman upgrade or update rather? Now Postman look different. Ah, gee, I don't know what I'm looking at anymore. This is not what Postman used to look like. I don't know what to do. Oh no. Okay, everything looks different. Let's create a new collection. Not a new collection. Anyway, we're going to make a GET request to, what was it? https://swappy.dev/api/people/1. Okay, and if I make that GET request, that's supposed to get back information about Luke Skywalker. Yeah, so that's the whole thing about Luke Skywalker. All right, so let's do the same thing in our code. So I'm going to specify that my server, I'm just going to make it so that the server is just the swappy dev part. So let me see. Cut this, I don't want that part. Or let me just cut all of this, I guess. Yeah. So this is my server, swappy.dev. Keep this here for later, so I can copy and paste it later. Okay, so next thing now, I'm going to want to set up my serial so that I can see the response in the serial monitor. So serial.begin, and use 115200. And then we need to actually connect to the Wi-Fi. So we're going to attempt to connect to the Wi-Fi now. So here's what we're going to do. This part I assume is going to be new for you. So we say Wi-Fi.begin, just like serial. And we begin using the SSID and the password. Oh, you know what I didn't do? I didn't specify how we bring in these values. We need to import the .h file that we just created. So I'm going to say include, and we use double quotes instead of angle brackets, and we can say config.h. I think that should work. So now with this imported, we should be able to make reference to those two variables we created called SSID and, is it pass or password? Password. And I'm able to do this because I defined these two variables in my config.h, and then I imported the config.h so that my code main.cpp can see those variables.
So is config.h another C file? Right?
It's a header
Like a main
file.
code.
So yes, it is. Sorry. I think because I'm hearing echo, I'm confusing it with you talking. Was that the end of your question?
Yeah.
Okay, yeah. So I was just saying it's a header file. It's something that we use in C and C++. It's something that's supposed to like be used to define constants and declare your functions and stuff like that. So it's a C related file. Answer your question? All right. So yeah, we're going back to setting up our Wi-Fi. So we make a connection to the Wi-Fi using the begin function. And then we're going to actually check to see if we're connected. So right here is just an attempt to connect. This does not guarantee that we're going to be able to connect. So we're going to print some stuff to the serial monitor to see if we're going to actually connect. So I'm going to say serial dot write print line. So here I'm just going to write and say that I'm making an attempt to connect. So I'm going to say connecting. And then I'm going to enter a while loop. And in my while loop, I'm going to continuously attempt to connect and check to see what the current status is. If I detect that my Wi-Fi status is connected, then I'll break out of the while loop. But if the status is that it's not connected, I'll stay in the while loop. So I'm going to say while Wi-Fi dot status is not equal to connected. If it is not equal to connected, meaning if I have not yet connected to the Wi-Fi, then I'll just delay and wait 500 milliseconds and just print a full stop. Print line. Just print a full stop to show that there's progress and we're waiting to actually connect. So what's going to happen in this while loop is as long as the Wi-Fi is not connected, it will just wait in here and just iterate through this and just keep printing full stops until it connects. When it does connect, it will break out to this while loop. And once it breaks out to the while loop, we know that we have successfully connected to the Wi-Fi. So then I can say serial.println, and I can say connected to Wi-Fi network with IP address. So this is a way we can display the IP address that we've connected with. Oh wait, I should use print here instead of print line so that it doesn't print into the next line. And then I can print serial.println the actual IP. So I can say Wi-Fi dot local IP. So this gives us our IP address. So I'm at this point, if you get to this line of code, meaning the while loop broke out, then you should have an IP address, and you'll just print it to say that you're connected to the Wi-Fi with an IP address of, and then this will print what the IP address actually is. All right. We're good with this so far? Is this okay? Let's test it.
We're going
to test it. So I'm going to build mine. Bill already? Oh, no, not build yet. Wait, did bill already? Oh.
Yeah, so when the Wi-Fi connects, then after some time, 500 milliseconds, then you just print whatever that is.
No, man. So this is if it doesn't connect. These two lines will happen if it doesn't connect. So it's going to wait a half a second.
The exclamation.
Yeah, that means not.
Mm.
Not equal. So it will continuously just print full stops until it connects. And then once it connects, it will break out to the while loop and then print this line.
If it connects, it does a connecting. Oh, connected to Wi-Fi. I think separate and apart from the code. When you're in a coding environment and you realize the cursor come up, the white block. So it's like it can't go up there.
Press insert on your keyboard like this.
Yeah.
Press insert on your keyboard.
Insert. Well, so what that did? What was it?
Insert. It will, instead of like, it doesn't put the cursor in between two characters. It puts it over a character. So if I type something, it can replace the character.
Yeah, that was an issue.
Yeah. Okay, mine finished building. I'm going to see if I can actually connect to Walkway's simulated Wi-Fi. So it's connecting, full stop. Oh, I used print. Oh, it worked. That's crazy. I didn't actually want it to print in a line. I wanted it to print horizontally, but it doesn't really matter. But yeah, so it connected to the simulated Walkway Wi-Fi. And I got a simulated Walkway IP address, which is good. So that means I should be able to make requests out to, wait, can I make a request to a local API? I don't know. I have to figure that out. Because that would make things a lot easier. Let me change this to a print. All right. Did we all get this working? Whether on your actual ESP or simulated. So remember, if you're doing this on your real ESP, you'll put your actual SSID and actual password for your Wi-Fi here. But if you're using the simulated Walkway, you type this exactly, Walkway guest, and no password.
You can drop that.
Sure. I will just copy this and put it in the WhatsApp. And the password is just, what's that? Oh, the entire thing, sure. Okay. So let me know if that works, and then we can move on to the loop. So that's how we set up. Oh, good. Yes or no? Guys, give me some feedback. How we stay?
We just add some unexport side code.
Say again?
Just add in the remainder code.
All right. Sorry, I was not paying attention. I know I answered you a while ago, but I don't know what you said. What you said a while ago?
So we just type out the remainder of the code.
All right. You can let me know if it works or not. We can come back to it. But we're going to go on to making a request to Star Wars server. So in our loop now, here's what we're going to do. We are going to start off by creating a new object that allows us to make an HTTP request. So I'm going to say HTTP client, and call that HTTP. So that's our HTTP object that we'll be using. That's our client. Then we're going to specify the path that we're going to be making the request to on the server. So that's like how when we make our server and we say that this particular function must be triggered if you make a request to /projects or /people. In our case, we're going to make a request to /API/people/1. That is something that's defined by the Star Wars server. So we need to specify that the route or the endpoint string endpoint is equal to, and that's going to be server name plus this. So we're going to make a request to this particular endpoint here. All right. And make sure that you don't have two slashes. So if the server name ends with a slash, you don't put a slash here. So my server name does not end with a slash, so I'll put the slash here. I think that's a common thing that people make mistakes with. Okay, so now, if I'm not mistaken, I feel like we can simply, oh no, we need 2 lines. Okay, first thing we're going to do is we're going to establish a connection to the server, or we're going to attempt to establish a connection to the server. HTTP dot begin, and we're going to make a request to the endpoint, or begin a connection to the endpoint. And the thing about this is the begin function. Wait, what? They changed it? I feel like at one point this didn't use to take capital S string. I think we had to use a C string at one point, but look at them change it. Because I was about to convert this to a C string, but it looked like it's actually okay. That's unless, let me check, are there any overloads? .c_string. Maybe it's just that it accommodates both. Okay, I have no idea. It says 6 overloads. All right, I guess you can do either one. Let's do it without it first and see if it works. So we'll just put the string there. Okay, cool. So now that we have established a connection to the endpoint, we should be able to just simply make a GET request now. So I'm going to make a GET request by saying http.get, and that's how you make the response. I mean, sorry, that's how you make the request. But after we make the request, we're going to want to get some information from the request, like, for example, what the status code was on response. So this actually returns the status code. So let's capture the status code in a variable. So int http status code is equal to that. So if the http.get returns a 200, then this value will be 200. If it's a 404, it will return a 404, and the 404 will be in this variable here. Whatever the status code is, it will be stored in this variable. All right, so let's start off. Let's just run this and see if it works. Wait, did I get a message on the call? Where's the call?
Yeah,
Oh,
I
you have a
mean,
question. Go ahead.
it it does connecting along
Here.
as if it's not getting it. So it does just connecting and then the dots, which mean it failed.
Oh, so it's trying to connect and it's not connecting.
Right.
Okay, and you make sure you have not equal to WL connected, right? In the
Yeah,
code.
that's why that print the dots.
And you make sure that you're using this exactly as it's typed out here with a capital W and a capital guest.
Yeah. Same thing with this.
Interesting. All right. Let me take a look at that, but let me make a test on my end first. What I'm just going to do here, I'm just going to make a request and see if I get back a 200. So I'm just going to print this.
Yeah.
Serial.print. I'm going to print the status code. So for now, we're just going to print the status code. If we get a 200, then we'll move on to printing the actual response. Okay, let me build this.
So which server we are connect to?
So I am connecting to the Star Wars API. So it's a testing API. Let me see if I can bring it up again. Yeah, so
Like that case of me now Star Wars API.
no, we all have access to it. It's on the internet. See, there's swappy.dev. This is the Star Wars API. It's on the internet. So you can just copy and paste this code. Let me put it in the WhatsApp. So we're making a request to the Star Wars API. So that's the server, and then the endpoint is this. So that's the server we're making a request to. Okay, mine built. Now let me simulate. And I should be able to, assuming that this simulator has access to the internet. So it's connecting, it connected. And now, is it gonna work? Oh, it 200'd. Good, cool. So it took a while because it took some time for it to actually build the request and make the request and get back a response. But according to this, we got back a 200, HTTP 200. Which is good.
My status code.
Come again?
Never mind, this is my error.
Oh, all right, cool. So yeah, I got a 200 back. So since I know I got back a 200, I can go ahead and then print the response. So let's add some more code to actually print the response. Let's do some checks. Let's check to see that the status code that we got back is actually a valid status code. So I'm going to say if what's it called, HTTP status code, or you can just call it status code. If it is greater than 200, sorry, if it is greater than 0, I'll tell you why I'm doing it this way. Hold on. Actually, no, let me not do it this way. Let me say if it is less than 1. If it is less than 1. So I would have taught you about the different status codes being like your 200 and your 201 and your 204 and all that stuff, right? This particular function that we're using, http.get, will return a valid HTTP status if it is able to communicate with the server. But if for some reason this function is unable to get to that server, for whatever reason, like let's say for instance, it don't actually have Wi-Fi or it don't have internet and we're unable to connect to the server, then it will return a value that is like, I think it's going to return -1 or maybe something else. I'm not even sure. But I do believe it will return a status code that is not in the expected status codes that we know. So we're checking to see if that happens first. So we're going to say if it is less than 1, meaning if it is 0 or -1 or something like that, then we will print the error code. I like writing it up here. We'll print the error code. So we'll say serial.print error code, and then we'll print the actual code. Can I just do this? Print line, and then print the status code that we got. Or if you want, you can make this more descriptive and just something like there was an error, and then say that the error code is this. There was an error. And in this case, this error means that it wasn't actually able to make a connection to the server. Okay, but if it was able to make a connection to the server, oh wait, you know what I need to do as well? I need to also return. So this return here is just going to make it so that the code stops here and then goes back up to the top of the loop and tries again. So what I'm doing here in this if statement is I'm just checking to see if there's an error, and if there's an error, stop the code here and start back from the top. Yeah. Ideally, I think it would be better if you did some checks to see if the Wi-Fi is connected, maybe somewhere up at the top of the code. And if it isn't connected, then you don't do anything, but I can leave you guys to research that. So all this does is it checks to see if there's an error, and if there is, it returns. And return just brings it back to the loop and tries again. So if this condition does not hold true, meaning we get back something that is greater than 1, then we're free to move on and assume that we got back a valid HTTP response. It does not mean, however, that we definitely got a successful HTTP response, but we did get back a response from the server. So if we did, then we can say that the serial.print line, we can say HTTP status code. I'll take out the ln. Sorry. And then we print the status code. Copy this. And then once we printed the status code, we can go in and we can actually print the response. So let me show you how you can actually get the response. We create a new variable, call it HTTP response, and we set that equal to HTTP dot get string. So get string will reach into the response body, and it will take the reach into the response body and just copy out all of the content that comes back in the response, whether that be the JSON that we're expecting to get back because it's a 200, or the message that says, you know, whatever is not found because we got a 404, or a different message that says bad request because we, you know, did a bad request. So whatever it is, whatever the response is, we'll get it back using the get string function. And now we can just print it. Serial.print HTTP response. Oops. All right. And once that's done, it's very good behavior. You see up here how we begun the connection. When you finish and you get back a response, clean up after yourself. End the connection. And then you're done. So we begin the connection. And once we get back up proper, you know what, I think we need to end the connection here as well. I think we need to end here. Yeah, I think it's good behavior to end there as well. That way you don't consume multiple connections without ending them. I think there's a cleaner way for us to do this, but I can't think about that right now. Anywho. So yes, let's test it out, see if it works. So according to Postman, if this actually works, I should get back a JSON that has a bag of information in it like this about Luke Skywalker. So let's test it. I will build.
Yeah, did HTTP status code get?
This. Oh wait, what are you talking about?
I initialize the HTTP status code. Yeah, that's
There.
No, sir.
Okay, I built mine, and now I can simulate. Let us simulate. Connecting to the Wi-Fi. Got an IP address. Now it's making the request, and I should get back. There is my JSON, and it's not pretty because we're just printing it as a string. So we're just printing the JSON as we get it. So we got the 200. Oh, look, I'm printing 200 twice, which is fine. So I got a 200. Then I'm printing the JSON response exactly as it appears in Postman. Yeah. So that's the first thing. Did you guys get this to work? Can you all test this? Tell me if it works, please.
Include HTTP end for the cleanup.
Yes, I did end. I did end 2 places. Here in the error handling and also at the very end. So it will do an end here and it will do an end here.
Yeah, scroll down.
That's the end of the code.
HTTP stuff. What? Yeah, probably said there was an error.
Here.
Oh yeah. So. It decreases the size of the terminal.
Okay.
Specifically, where we get the Wi-Fi to connect because
The setup.
it's still as a connect thing.
Oh, you want to share your screen?
That thing now.
Oh,
A
because you have
different
different
thing right
values.
now.
Yeah.
I'll try it.
Okay. All right. So that was how we can just simply get the response and print it as a string. But here's the thing, right? Just getting by the response from the request and just keeping it as a string. That's not very useful. What would be a whole lot more useful is if we could actually treat this like a dictionary. So you remember how like in Python, you could get a dictionary from the request and you could either specify what values are supposed to go where, or you pull out the values and you use them in your code. So like for example, if I wanted to print specifically just the Luke Skywalker part, I would have to reach into this JSON or this dictionary and pull out the Luke Skywalker by using the name and being able to print it that way. But we can't do that because this is not a dictionary. This is literally just a string, which is here, right? So it's not like we can do a thing like this. We can't say HTTP response and then do a square bracket and then say name. We can't do that because it's not a dictionary. It's not a JSON. It's a string. You can't do this with a string. See all the errors that I'm getting? Can't do this. We could technically do this where we just get like 0 or 1 or 2. But what that would do is it would return the third element inside the string. So this would actually just return the letter n in this case, because strings are treated like arrays. So this wouldn't actually give us any very meaningful information. So what we need to do is we need to take this what's it called? We need to take this dictionary string and we need to deserialize it into an actual meaningful object that Arduino or C can use to treat it like a dictionary or a JSON or an object. All right? And we're going to be using a library to do that. And I am considering not using this particular request because this JSON is really heavy. Let me see if I can find a lighter request. The reason I say it's heavy is because it comes back with a lot of data. And I don't want to have to convert all of this into a JSON because it's a whole heap of stuff. So let me see if I can find a different endpoint that returns a smaller JSON. Test API, test HTTP API. What on earth is all of this? Rec bin. Does this work? Oh, this is how you post. I don't want post. I want to get. What does this return? Oh, yeah, this is easy. Let's use this. How do you make a request to this? So it's saying we need to make the request to recbin.com. So that's my server. I need the https:// and then make the request to echo get JSON. So put this here. All right, let's see what this looks like. I'm going to build this and hopefully I'll just get success equal true, which is much simpler. Okay, successfully built. And now I will simulate. Whoops, no, that's not what I wanted to have happen. Okay, simulate. Connecting to the Wi-Fi, connected, and it should say, I should have tested it in Postman first, you know. Okay, good. We got back response. Success is true. All right, that's much easier for us to use because it's way smaller. Let's wait until it prints it again. Okay, good. Cool.
Cool.
Matthew? Good?
Good.
Hello? Okay, cool. All right. So, here's what we're going to do is we're going to add a library to our code that allows us to take a string and convert it into a JSON. Matthew, you were concerned about importing libraries into your setup or into your project. Hopefully the way I'm going to show you is different from the way that you're familiar with doing it, to show that it is relatively simple. So I'll go to PlatformIO on the left, and I will click on libraries here. And then I'm going to search for JSON. Press enter, and we're looking for Arduino JSON by Benoit Blanchon. For some reason, for years, I've been calling this guy Brandon, because his name, when you look on it, it just look like Brandon, even though his name is not Brandon. So if at any point I tell you to search for Arduino JSON and click the one from Brandon, is this one we're talking about. So I'm going to click on this, Arduino JSON, and I'm going to click on add to project. This was updated 3 days ago. It must be good. So I'm going to click add to project. And I'm going to select project. And the project I'm going to select is the one that we just created. What's it called again? Jaja. I think it was called Blink. I can't type. What kind of foolish is that? Hold on. Am I zoomed in too much? Hold on, let me zoom out. I can't zoom out. Guys, help. Hold on. Okay, I'm zoomed out now. So go back to this, add to project, select project. Why can't I type? All right, let's search for the project that you just created a while ago. Mine is called this. Boy, I hope is this. And then click add. Teresa, I have a question.
Did you say the work is supposed to generate its own Wi-Fi?
It allows us to connect to a simulated Wi-Fi.
Where is that Wi-Fi running from?
I think it's just connecting to the internet. It's not actual Wi-Fi.
So
It's just
where you have a
simulated.
blank password.
Correct.
It's just
It's
supposed to be
blank.
I mean, the code I upload, but still, I get not sure if it's a connecting.
Okay. So yeah, I added the library to my project, and what it did is it created a new entry inside the platform.ini. That's this file here, and it created a libdeps variable or library dependency variable, and it added the Arduino JSON library. So this is the publisher, this is the name of the library, and this is the version that we just installed. And I think with that, we should be good. It's installed. We don't need to do anything else.
So we can get the name of the server. Like connect now.
Sure thing. On six. Our server is called recbin. Copy this. And the endpoint is echo get
You think you can switch it to my Wi-Fi?
You're using a physical ESP, right?
Yeah.
Yeah, you can. All right. So I now have Arduino JSON installed. So now I just need to import it. So let's import it. So I'm going to say include in angle brackets Arduino JSON. Is JSON in a capital letter? It is not. JSON.h. And that should be it for that. Now it's imported. Red underline should go away in just a moment. Right? Did I spell it wrong? Arduino. Oh, I did spell it wrong. Arduino. Good. Okay, it's gone. So arduino.json.h. Sorry, arduino.json.h. So let's use Arduino JSON now. And let us, instead of just printing the raw, where are my notes? Instead of just printing the raw response string, guys, where are my notes? This, not this. This. Is it this? Guys, I'm blind. Hold on. Unless I closed it. Did I close it? Oh, here it is. Okay. Right. So we should be able to use Arduino JSON now. Oh, you know what we need to do? So there's some code that we're going to have to implement in our sketch, right? And this code, I usually don't write it from memory because it's kind of hard to remember and I don't remember how to do it. So what we normally do is we use a tool that we get from the Arduino JSON website. There's a website created by Brandon himself.
So you can just see the endpoint name.
Come again?
Again?
The name of the endpoint.
I send the whole thing in what?
And the whole thing.
JSON. So there's a wizard that we can use. Okay, so yeah, let me see. So we search for Arduino JSON and it gives us some documentation on how we can convert our strings into actual JSONs. So there are two things that we can do. We can serialize or we can deserialize. Right now, since we're performing a GET request, which is we make a request and we get back a JSON response and we want to use that response in our code, we will deserialize. Deserialize means you take a string and you turn it into a JSON. Serialize is if you created a JSON firstly on the Arduino and then you wanted to turn it into a string so that you can use it as the body of a request. So we're going to do deserialization because we are making a request, or sorry, yeah, we're making a request to get back a JSON. If we're doing a post request, we'll be using serialization, but we're doing a get request, so deserialize. So there's supposed to be a thing here. Is there a question? Where's my window? No? All right. So let me see. There's supposed to be, where's the wizard? The assistant. Here's the assistant. So it asks us what we're doing. Oh, actually it asks us which board we're using. That's really cool. They never used to do that. So it asks us which board we're using. We're using the dev module. And do we want to deserialize or serialize? We want to deserialize. And the input in our case is a string. Yeah, so we put in all this information and we'll click next. For now, oh wow, they remember this from last year. That's crazy. So now what we want to do is we want to give it an example of what the JSON is that we're trying to deserialize looks like. So I'm just going to copy this because this is what our JSON will look like. And I'm going to paste it here. Can I pretty it? Yes, pretty. Okay, so then pretty. So we tell the wizard or the assistant what the JSON that we're expecting to get back will look like. The reason why we're telling it what it was going to look like is because the JSON, sorry, the assistant, I keep calling it wizard. I think it used to be called wizard. The assistant needs to know how it's going to allocate the memory for each of the different values and key value pairs in the JSON. So in our case, we have a single key value pair. The key is success and the value is true. As a matter of fact, do I want this to be true or should it be a Boolean? All right, well, in this, it looks like a string. All right, it won't be a Boolean. So what I should be able to do is go here and just click program. And it gives us the code. So it starts off by telling us that we need to create a document or a variable of class JSON document. Then we're going to attempt to deserialize it. Let me just copy all of this. And then step 311. Copy this, go into our code, and then I'm going to replace this with that. And let's step through this code. Okay. So first, we start out by creating a document. This document is where our JSON is going to live after it's been created, or object rather. Okay, so first line is we deserialize the JSON. Deserialize JSON takes two things. It takes the document object, which is created here, and it takes the string that we're trying to convert. In our case, the string is not called input, it is called HTTP response. I really hope that's why it's complaining. Yes, it is. Okay, so we take the document that it's going to create, and it takes the string of the JSON that we have here that we got from the response, and it will make an attempt to deserialize it. This says error because if this fails, if this function call fails, it will return an error. But if it passes, it will not return an error. So we use this to check to see if there was an error during the deserialization process, which is why I have a if statement here that says if error, meaning if error is true, if there was in fact an error, we print some text that says that the deserialization process failed and this is why it failed, and then we return. But if it doesn't error, if it does not throw an error, then it will not run this code and it will move down here, and we can simply access the values from our document just as it appears here in the JSON, where it said down here, it says it's a single key value pair of success equal true. So you have doc. If you want to get the value true from it, you just access it by using its key success, and that should store, well, we don't know that it's called success. In this case, you can just name this this particular variable anything you want, and it will store the value of true. And then we can just print it. So let's print it. So serial print line success. Okay, let's build this. In the meantime, ask me questions. What's not clear? What part of it do you want me to do again?
Serial input
Come again?
from the serial input down.
Sorry.
The string input.
String input?
So you lost me from my group on the website.
Lost you from when?
Website, the JSON assistant.
Oh, okay. I'll do that again. Tyrese, what were you saying? I didn't hear what you said.
I was saying for the code from the string input down. So from where we stopped.
Okay.
Then when you added a JSON document on the serial.
No problem. Let me do it again. Let me just make sure mine work though. Okay. Diagram. So it's going to make a request. Okay, it printed the true. And the fact that it printed the true means it actually went into the JSON, or rather it got the string, converted the string to a usable document that can be used in C++, and it extracted the value using the success key and got back true and printed it. But yeah, I need to explain this again because I guess it wasn't clear the first time, which is fine. So let me get rid of this code here. Okay, just to make it very clear, at this point, with what the code I have on screen, all we're able to do is get back the response from the request that we made and treat it as a string, right? This here, this response that we print is just a string. It does not have any inherent value, or rather, it doesn't have any inherent value in the context of our code. It's just a string of characters that says success is true with some curly brackets. It is not data, or rather, it's not information, it's just data. All right? So what we need to do is we need to take this string and convert it into a JSON, or rather into an object, so that our code can actually use the values inside the JSON. For example, just a while ago I had on screen in my assistant that looked something like this. So I had a curly bracket that said fan is true and light is false, right? Ignore the red underline. So let's say, for instance, I had two relays connected to my ESP. And both those relays were connected to, wait. Okay, no, I wouldn't be able to test that now. But yeah, I had two relays connected to my ESP. And one of those relays was connected to a fan, and the other one is connected to a lamp. If I were to make a request to some server and get back this JSON as the response, I would want it so that the fan turns on because this says true and the light turns off because it's a false. But at this point in my code, if I were to just get the response and it comes back as a string, I would not be able to use anything in the code that I have at the moment to be able to interpret the value of fan or light as true or false. Because this, or let me see, if it were to come back that look something more like this, this is more like what it would come back as in the code. If it were to come back as this, we wouldn't be able to use this because it would effectively just be something that looks like this, which is just a string, right? So we can't use this as any actual information. We can't go into this string and extract the true from it or extract the false from it. Not unless we actually knew exactly where the word true was and exactly where the false was. Assuming we knew that this was saying true and this was saying false. We'd have to use some string manipulation to read it and find the word true. And if it says true, then we'd use it. And if it's a false, we use it. But that's complicated and it has too many edge cases that we would not be able to account for. Or we would be able to account for it, but it would be too complicated. Anyway, instead of interpreting this as just a string, we want to take this string and make it into a document or an object that we can reference the values inside of. We want to be able to check to see what the value of fan is and see if it is true. And we want to be able to see what the value of light is and see if it is true or false. Yeah? So we need to convert this from a string into an object. So that's what we're using Arduino JSON to do. So I was using the assistant on Arduino JSON to walk us through what code we'd need to convert that string into an object. Clear so far? Before I continue, let me know if we're good.
Yes.
Come again?
That's a lot for us so far.
All right, cool. So what I was saying, let me go back to this previous page. We have two different methods that we can use: serialization and deserialization. Serialization is when we start off with an object in the code and we want to be able to take that object and convert it into a string so that we can use it as the request body so that we can send off a request, for example, a post request. You'd more than likely want to use serialization if you had some sensors on your ESP that you're reading from and you want to be able to create a JSON to post to a server. So like you have a temperature sensor and a humidity sensor on your ESP. You read the values from it, and then you create a document that looks like this. And you will set the temperature value to be whatever temperature you measure, and the humidity value to be whatever humidity you measure. And then you'd serialize that into a string, and then you'd make a post request and send that off to your server. That is serialization. What we want is deserialization, where we start off, we make a request to a server, a GET request to a server, and we get back a response. And that response comes back in the form of a string. It's a JSON string, right? As a string, it means nothing to us. So we want to take that string and turn it into an object so that we can extract the values from it. So that's where we're using deserialization. All right. And I use the assistant because we can give the assistant some information about our environment and our setup, and it can write the code that we need for us. Okay, so among a few things that it asks us, which ESP we're using or which microcontroller we're using. The microcontroller that we're using is the ESP32 dev module. So we just leave it at that. Next, it asks if we want to deserialize or serialize. Based on what I explained a while ago, since we're performing a GET request to the recbin server, we want to deserialize because we're making a GET request to the server and we're getting back a response in the form of a JSON string. Then it's asking us what is the data type of the response that we get back. We could use any one of these depending on how our code is set up, but we're using a string. The reason we're using a string as the input is because we get back the response, or is it get string, as a string. So our response is of type string. Yeah. So we use string. I'll stop here. Are we good? Like,
Wait, restate that part.
I'm saying, you understood the deserialize and the serialize part?
Yeah.
So I'm saying that as the input, it's asking us what is the data type of the data that we want to convert into an object. And I'm saying that we're using a string, capital S string, because in our code, that is the data type of the response that we got back from the request that we made. String, capital S string. So our JSON string is of type string. There are other data types that we could have used, but in our code, we use a string. So I specify string. Good?
Makes sense.
All right, cool. Next is the JSON. So on this screen, the wizard or the assistant is asking us, the JSON that you're expecting to get back as a response from the server, what does it look like? What are some of the attributes that they're expecting to get back? So I would have just copied and pasted the exact response that we got back from the server to tell it exactly what we're expecting to get back from the response. And that way it will be able to look and tell us that it's expecting a variable or a key called success. And the value of success is going to be a string. In this case, it's a string because it has the double quotes around it. But let's say, for instance, it was a different thing where we wanted to deserialize something that looked like this. I have a fan, and that is true. And I have a light, and that is false. And in this case, I'm using the Boolean without the double quotes. I can print this. All right. So I have a JSON that returns a fan and a light, and they're both Boolean. I would next go to program, and it would tell me that the first thing I need to do is create an object or a document of type JSON document. Then I run this command to make an attempt to deserialize it. And deserialize means convert it from a string into an object. So this function takes two things. It takes the empty object and the string that we want to convert to an object. And it will read and parse this input and convert it into an object and hydrate it into this variable. And the function will return an error if there is any. So if this function returns an error, this value error, this variable error will become truthy. Remember I talked about truthiness and falsiness yesterday. And if it is truthy, this if statement will check to see if there's an error, or check to see if the value of the error is truthy. And if it is, it will give us the error and tell us that there's something wrong with the deserialization process. And it tells us what the error is by using this. and then it will return. And this will just end the code right here. But if the value of error is falsy, meaning there is no error, and the deserialization process succeeded, then this code will not run. And it will just move on to this. And it will just show us that the values that we have inside of the JSON document here, the JSON document, the first value that I have here is document and square bracket fan. It's giving us an example of the type of value that it would store. In this case, is true. So we store that in a Boolean. And the value for light is false, so we store that in a Boolean. Yeah. So this is how it would work if that is what our JSON response from the request that we made looked like. Yeah. But we're not working with a fan and light JSON response. We're just working with success is true. And in this case, true is not a Boolean, it's a string. So that's why we're not going to be using this. But before I go back, did that make it any clearer? Is it better now?
Okay.
Yeah. Okay, so let me go back and change this to what this told me it is. Put to that in the next program, and this will get back. So I'm going to copy this code, replace this, and there are a few assumptions that it made. It assumed that our JSON string was going to be called input, so I'll just replace that. Copy this, put it here. So this is our JSON string, and this is the object document that it created here. This function will make an attempt to deserialize the object, or the string rather, and turn it into an object. If it errors, it will run this code, but if it does not error, it will skip over this code and come down here. And I'm now able to get the value of the success key inside of my object, and it will either be true or something else as a string. So we don't need this. So this stores the value. So now I can just print this. Was that clearer? If it wasn't clearer, I would suggest that you go and do your own research or experiment yourself. Try it out yourself. See if you're able to build, not even build, just use one of your APIs that you already have on your code, on your laptop, and see if you can make a request. Actually, I don't know if you can make a request to your locally served API. You may have to just use the test APIs that we have access to, either the Swappy or the Recbin one that I'm using here. But yeah, ask me questions. Tell me what's not clear. Or do you need some time to just try it yourself and come back? Let me know.
So to get the whole deserialization code, you get it from the website just now.
Yeah, let me copy and paste that. It is not to say that we need the assistant though, you know. I just use the assistant because I don't remember the code out of my head.
Mm.
And I never have. Every single year that I teach this class, I always use the assistant. And it's never stuck in my head. But that's fine. So that's the assistant. You can use that to tell you what code you need to write depending on what the shape of your JSON string is.
So what I need for the upload back.
Come again? Oh yeah.
Upload back to the ESP.
Yeah. So make the change to your code and then re-upload. And I will just simulate.
Alright, so the serial connected. There's a my one. Wait, it fixes. It's a HTTP successful. 200.
How much? 200?
Yeah.
Okay, that's good.
Then Then you say your thing, Luke Skywalker.
Okay, that's you're still using the swappy. So if you want to, you can test out using the swappy in the Arduino JSON assistant. You can go through the same process I did. Copy out the entire string that you got back in the response.
So from the 200 comes straight.
Not from the 200. Copy from the curly braces to the curly braces. The opening curly brace to the closing curly brace. And just paste it in the assistant. That's probably going to be really heavy though.
Heavy.
But maybe the ESP can handle it because the ESP is a beast.
It should be a string. Yeah, string.
Yeah. How
This
is the
is-
otherwise? Matthew, Reina, Richard, how is the? Any questions?
Dev kit.
Alright, silence me, you guys good. If you have questions, you know where to find me.
Yeah.
Yes, sir. Never watch over the video.
Alright, no problem. Yeah, man. Alright, cool.
We can fall back to configuration.
The config? Which config?
DOIT dev kit.
What?
The
Google Drive, is
Arduino assistant.
Oh, yes, in the assistant. This your type?
Fall back to configuration.
Oh, here. I use dev module.
So it's dev ESP32 dev module. Try something. So paste all of that, press JSON, and then press next program. Alright, so give me something pretty heavy. So just paste it below serial print HTTP response.
And you likely don't have to print. Well, it gives you all the variables. You can choose whichever one you want. For example,
JSON. So JSON document is undefined.
JSON document. Oh wait, hold on. This don't seem all that heavy. According to this, it's pretty low. 1.2 kilobytes. Okay, maybe it's okay.
Failed. Identifier deserialization is undefined. And you should import that.
I never import anything. Did you change the? Did it give you input right here? So change that to HTTP response.
Yeah, input again.
Yeah, change it. Change it to HTTP response. Or whatever you call your response variable.
I think it's still also the same thing.
So I can just print Luke Skywalker.
Mad errors. Find out some. We don't know how to solve this. 10 errors.
But yeah, so that's gonna bring us to the end of today's session. The next time we will look into making a post request.
And for add
What's that?
thing that for add Arduino JSON.h
Oh yeah, you have to do that up here.
dynamic JSON document instead of JSON document.
Yeah. Oh yeah, I have to jump off now. So we'll end here. And we'll continue again next week, Wednesday.
Maybe I get lab.
The lab tomorrow is going to be on the stuff that we have done before this point. So next week we do lab on Arduino. This week we do one more fast API lab. So you'll get that tomorrow.
First one again for the mid semester. It's the day and the content.
Come again?
The day of the mid semester and the content.
Oh, I will get back to you on that. Maybe tomorrow I'll tell you. Alright.
That is it.
Alright, cool. See you guys.
Alright.